Okay, this question is about acids and alkalis. Give all pHs to 2 decimal places. So I'm just going to make sure that I don't forget that. So this is a pH. Scroll through, that's a pH as well. So 2 decimal places. Weak acid, and then here I can see this in bold already, 3 significant figures, so I may as well put myself a reminder there. And then calculate the pH here as well, so 2 decimal places. So there's all my reminders. So nitric acid is a strong acid. Calculate the pH of a 0.1 mole decimeter cubed solution of nitric acid. So pH is minus log of the hydrogen ion concentration. Nitric acid is HNO3, which means it has 1 hydrogen ion, so it's the minus log of 0.1, which is equal to 1.00 to 2 decimal places. Okay, part B, 50 centimetres cubed of sodium hydroxide was added to a beaker containing 22.5 centimetres cubed of 0.1 mole of sulfuric acid. Calculate the pH of the solution formed. So let's start with the number of moles of hydroxide is equal to, so 50 times 10 to the minus 3 times 0.125 equals 6.25 times 10 to the minus 3. And then the number of moles of H+. Now, sulfuric acid is a dibasic acid, so there's going to be 2 hydrogen ions per mole of sulfuric acid. So I'm going to times that by 2 here. So 2 times 22.5 times 10 to the minus 3 times 0.1, and that equals 4.5 times 10 to the minus 3. So you can clearly see that this is in excess. So number of moles of hydroxide that is left over is going to be equal to 6.25 times 10 to the minus 3 minus 4.5 times 10 to the minus 3, which is equal to 1.75 times 10 to the minus 3. So that's the number of moles of hydroxide that I've got left in the new total volume. So the concentration of the hydroxide is going to be number of moles, 1.75 times 10 to the minus 3, divided by the new total volume, which is 50 centimetres cubed plus 22.5, that's 72.5 times 10 to the minus 3, and that equals 0.0241. So the hydrogen ion concentration, now I need to use Kw, which is 1 times 10 to the minus 14 divided by the hydroxide ion concentration, which is 4.14 times 10 to the minus 13, and then the pH of this minus log of 4.14 times 10 to the minus 13, let me make that clearer there, minus 13, gives me, and I've got my little reminder down here, 12.38. So here's where the marks are. So there's 1 mark for that, 1 mark for this, 1 mark for this, 1 mark for this, 1 mark for this, and then so 1, 2, 3, 4, 5, and then obviously 1 mark for the correct answer to 2 decimal places. Okay. Part C, ethanoic is a weak acid. Define the term weak acid. So it partially dissociates or ionizes. Okay, you can't say it doesn't fully dissociate. You've got to say what it does rather than what it doesn't do. Okay, so that's a recent thing in the mark schemes. And then 2C part 2, calculate the concentration in moles per decimeter cubed of a solution of ethanoic acid with a pH of 2.45. So what have we got? We've got Ka over here. So let's start with the hydrogen ion concentration from the pH. So 10 to the minus 2.45, which equals 3.55 times 10 to the minus 3. So for a weak acid, Ka is equal to H plus. So for ethanoic acid, it's going to be that. But of course, these two are equal to each other, so I can simplify that a little bit to H plus squared over CH3COOH. So put my numbers in, or rearrange it to get my concentration. So CH3COOH is equal to Ka times H plus squared, which is 1.74 times 10 to the minus 5 times 3.55 times 10 to the minus 3 squared. And that gives you 0. And again, I've got my reminder here, 724. So where are the marks on this one? Well, there's 1 mark for calculating that. There's 1 mark for writing the expression. Any one of these expressions is absolutely fine. So this one, or this one. And then 1 mark for this marker over here. Okay. So part D, a buffer is formed when sodium hydroxide is added to an excess. So you're told that you've got the acid in excess. Calculate the pH of the buffer formed when 1 gram of sodium hydroxide is added to 10 centimetres cubed of ethanoic acid. Right, okay, so number of moles of hydroxide. So if you don't know what to do, just calculate whatever you can, and you can work out the moles of sodium hydroxide. So it is 1 divided by the MR, which is 40, which equals 0.025. The number of moles of ethanoic acid is equal to, so concentration times volume, so that's 100 times 10 to the minus 3 times 0.4, which is 0.04. Okay, so you're told that this is in excess, so you need to take this away from this in order to get the number of moles of acid left over, but also this is going to give you, probably better if I do it as an equation. So the buffer solution is made of this and this, okay? So if I put my moles in that I've got here, I've got 0.04 moles of that, 0.025 moles of this, and obviously at the beginning I've got none of either of those. So this is in excess. So what I'm going to do is 0.04 minus 0.025, and that equals 0.015. So that's the moles of my acid in the buffer. But to get my moles of this over here in the buffer, so this react in a 1-to-1 ratio. This is my limiting reagent here. So I'm going to make 0.025 moles here, so 0.025 moles. Okay. So my equilibrium expression is this. Now, because it's a buffer solution, these two here are not equal to each other, so I can't remove those. Okay. What I have got in here, though, is got Ka from earlier in the question. I've got that. That's this bit. That bit there. And this bit is that bit there. So let me rearrange this to get H plus on its own. So H plus equals Ka times CH3COOH all over CH3COO minus, which obviously comes from this up here. So let's do the calculation then. So let's put Ka in. So Ka is 1.74 times 10 to the minus 5 times the ethanoic acid, that's this one here, 0.015, all divided by the ethanoate, which is this bit here, so 0.0025, and that gives me 1.044 times 10 to the minus 5. So the pH then is equal to minus log of 1.044 times 10 to the minus 5, which gives you, and again I've got my little reminder here, 4.98. And you can see how important these are, because this is quite a way onwards from the question when it told you to do it to 2 decimal places. Okay, part E, state how the buffer formed in D resists the changes in pH when a small amount of acid is added. Okay, so when the acid is added, so H plus reacts with CH3COO minus, therefore removing added acid. Now, although there is an equilibrium involved, the exam board want you to talk about what reacts with what. So it's H plus reacts with that. If it was the OH minus, you would say that it reacts with the H plus. Okay, there we go.